Assalamu alaikum. As the students were asked that they will be also trying to apply the number synthesis up to more than one DOF mechanisms, two DOF mechanisms, 3 and 4 DOF mechanism. So to assist them, I have also tried to help them. So number synthesis application to 3 and 4 DOF mechanism. So I have not elaborated here the application to 2DF mechanism because already a solution in the problem has been given in the numericals. So because there is no numerical or problem available which actually demonstrate the application of number synthesis to 3 and 4 DOF mechanism, so I have explained it here. So for DOF or M is equal to, M stands for mobility, means DOF stands for degree of freedom and M stands for mobility. So these are alternatively used terminologies. So if DOF is equal to 3 and the number of links up to 10 links, 10 links and up to the hexagonal order have been tried here. So the detailed procedure that I will be have written and I will be explaining it. So assume DOF is equal to 3 and the number of links must be even as DOF is equal to odd. So if DOF is equal to DOF is odd number, then the number of links must be even. So number of link must be even if DOF is odd. So again I have referenced it here the equation 2.4a from the textbook of design of machinery. Again I will be showing here. This equation 2.4a on page number 44 of the book 6th edition design of machinery by R.L. Norton. So this is the equation, first equation and the other equation is equal to L minus 3 minus M, which is equation 2.6 here again shown here as you can see, L minus 3 minus M T plus 2Q plus 3P plus 4H. So I have referenced these equation and the same reference numbers are shown here. So if for DOF or M is equal to 3, so equation 2.6 which will give you L minus 3 and minus 3, so this will become L minus 6 is equal to T plus 2Q plus 3P plus 4H. So as we can observe on the left hand side there is L minus 6. So we will be randomly trying and as we can observe that here that the total number of links, because L is the total number of links and that cannot be less than 6. So again L is not less than 6 because such as for example 2 or 4 because they must be even, because that will require negative number of links on the right hand side, so which is impossible. So that means we can start from L is equal to 6. So the lowest number of links that will be required for a 3 DOF mechanism, that will be 6. So this equation number 1, that will give 6 minus 6 is equal to 0. So T plus 2Q plus 3P plus 4H will be equal to 0. And as on the left hand side there is 0, so that means if there is 0 on the left hand side, that means that none of the links can adopt other value than 0. So all links means ternary, quaternary, pentagonal and hexagonal links all must be 0. That means there cannot be any link ternary, quaternary, pentagonal or hexagonal link. But as we can observe that in this equation binary links are not available, so binary links will be obtained from this equation 2.4a. So now we use equation 2.4a to determine the binary links. So in this equation we have input all other binary, ternary, quaternary, pentagonal, hexagonal look to be 0. So this equation gives b is equal to 6. So the first combination for DOF or m is equal to 3 is b6 means, which means minimum all must be binary links for L is equal to 6 and M3 case. So if the DOF of the mechanism is 3 and the minimum number of links must be 6 and all must be binary links means all having 2 nodes. So the first combination for M3 is equal to b is equal to 6 and all ternary, quaternary, pentagonal, hexagonal links must be 0. So there is only one combination. So the next try from this equation number 1 we can observe that L must be greater than 6. So the next value can be 8. So L is equal to 8 even for odd, M DOF is equal to 3 is odd. So equation 2.6 gives in a similar manner that L minus 6 or 8 minus 6 is equal to 2 t plus 2q plus 3p plus 4h. So 2 is equal to t plus 2q plus 3p plus 4h. So in this way this equation will be obtained. And now we observed in this equation from the highest order, and as we can observe the highest order link in this equation is H. So we have started from the highest order link and its lowest count, its lowest number, and lowest number can be 0 or 1, and in this way that we will be proceeding or increasing their count. So in this equation we can observe that because here is written 4h, so even if h is equal to 1, that means on the left hand side the equality will be equal, equality cannot hold. That means 2 can never be equal to t plus 2q plus 3p plus 4, because none of these links t, q and p can be the can obtain or adopt the negative value. So that means if these are all links are positive values, that means equality cannot hold. So that means h can only adopt 0 value if L is equal to 8 and 3 DOF is there. So that means there can't be any hexagonal link for L is equal to 8. So that means both P and H, also P cannot be equal to 1, because if P is equal to 1 then there will be plus 3. So on the left hand side there is 2, so it is also unsatisfying. So both P and H must be 0. So P and H are 0 to hold the inequality. So the equation will be reduced to 2 t is equal to 2 is equal to t plus 2q, and equation number 3rd will be giving 2 values, because here again we will starting from the highest order link, which in this equation is quaternary link, and its lowest count means 0 or 1. So if q is equal to 0, we obtain t is equal to 2, and the equation 2.4a that will be giving b plus 2 and all other values are 0. So in this way b will be equal to 8 minus 2, which will be equal to b is equal to 6. So the first combination for m is equal to 3 and l is equal to 8 will be 6 binary links, and two ternary links, and all quaternary, pentagonal and hexagonal links will be 0. Means there will be no quaternary, pentagonal or hexagonal links if there is to be total 8 number of links, and 3 DOF mechanism is to be designed. So the first combination for M3 and L is equal to 8 has been obtained. So to obtain the second combination, we use the next value, or Q is equal to 0 or 1. So we will be using the other value, Q is equal to 1. If Q is equal to 1, we observe that T will be equal to 2 minus 2, that means 0. So this will giving you T is equal to 0, and the equation 2.4a will be giving, we can observe that will give that total number of links are 8. So 8 minus 1, so binary links will be 7. So the second combination for M is equal to 3 and L is equal to 8 will be 7 binary links and 1 quaternary link, and all ternary, pentagonal and hexagonal links will be 0. So none of them will be can exist in the linkage if there are total 8 links and 3 DOF mechanism is to be designed. So in this way, L is equal to 8 can obtain can give only 2 combinations for 3 DOF. So now we will be trying the next value in this equation. L minus 6 is equal to T plus 2Q plus 3P plus 4H. So the next value will be a positive number of links, because the DOF is odd, so that is 10. So L is equal to 10 will be tried. So here, as we can observe, L is equal to 10, which is even for DOF, or M is equal to 3 odd. So equation 2.6 will give like this, that L minus 6 and this, and so 10 minus 6 will be equal to 4. So 4 will be equal to T plus 2Q plus 3P plus 4H. So here this is the deciding equation, and in this equation, as we can observe, that hexagonal link, we will be starting from the highest order link, which is hexagonal in this equation. So its lowest count or lowest number, that can be 0 or 1, and in this way that will be increased. But as we can observe, that H can adopt only 0 and 1 value, because if H is equal to 2, that means 4 multiplied by 2 will be 8. So 4 will be equal to T plus 2Q plus 3P plus 8. So that means 4 minus 8 will be equal to minus 4. So the sum of T plus 2Q plus 3P will be equal to minus 4, which is impossible, because that will be requiring some of the links to adopt negative values. So which is impossible practically, because physically links can't be negative. So in this way we can observe that H can only be 0 or 1, and we can observe that for if H is equal to 0, this equation will give you T plus 2Q plus 3P is equal to 4. So again we will be repeating the same procedure, that here the highest order link is pentagonal link. So we will be starting from the pentagonal link. So pentagonal link can only adopt 0 or 1 value, because if we put P is equal to 2, that means 3 multiplied by 2 will be 6. So in this way 4 minus 6 will be minus 2. So T plus 2Q will be equal to minus 2, which is impossible, because none of the links can adopt the negative value. So P can be 0 or 1. So if P is equal to 0, we put in this fifth equation. So if P is equal to 0 in this equation, so t plus 2q will be equal to 4. Again in this equation we will again be starting from the highest order link, which is quaternary link, and it can adopt only 0, 1 or 2, means 3 values it can adopt. It cannot adopt uh, value greater than 2, because if for example q is equal to 3, 2 multiplied by 3 will be 6, so 4 minus 6, that will be minus 2, so t will be equal to minus 2, which is impossible, because no link can ever adopt or assume negative number or negative values. So in this way we can observe that q is equal to 0 or 1. So starting from if q is equal to 0, in this equation number 6 we observe that t plus 0, that means is equal to 4, so t is equal to 4. So in this way the equation number 2.49 will be giving that ternary link will be 4 and quaternary 0, and all pentagonal and hexagonal links are already 0. So in this way 10 minus 4 will be equal to 6, so binary link will be 6. So the first combination for L is equal to 10 and M or DOF is equal to 3 is 6 binary links and 4 ternary links, and quaternary, pentagonal and hexagonal link must be 0. So the first set for M is equal to 3 and L is equal to 10 has been obtained. So now we will be using the next value in this equation. Q is equal to 0 has been used, so Q is equal to 1. So we will be starting from this lower equation to proceed to the parent or previous equation. So we will be inputting q is equal to 1 in the same equation. So if q is equal to 1, we can say that 4 is equal to t plus 2, so t 4 minus 2, which means t is equal to 2. So there are 2 ternary links and 1 quaternary link. So the equation 2.4a will give that binary links, so t2 and quaternary link is actually 1. So in this way here are some typing mistake. So again total number of links are 10, so 10 minus 3 will be equal to 7. So the second combination for L is equal to 10 and M is equal to 3 is equal to B7, and 2 ternary links and 1 quaternary links. So and pentagonal and hexagonal link must be 0. So second set for M3 and L10 has been obtained, and the last value that here we had assumed, that is 2. So if q is equal to 2, we can observe that 4 is equal to t plus 4, so that means 4 minus 4, so t is equal to 0. So the other equation will be giving the binary link values, so t is equal to 0 and quaternary links are 2 and pentagonal and hexagonal are 0. So 10 minus 2 is equal to 8. So the third combination for L is equal to 10 and M is equal to 3 is 8 binary links, 2 quaternary links, and ternary, pentagonal and hexagonal links all are 0. So in this way third combination has been obtained. So as we can observe that the quaternary link, all its assumed values have been satisfied. So we will be proceeding backward, that p had assumed the 0 or 1 value. So for p is equal to 0 has been solved, so we will now be solving for p is equal to 1. So in this way here it says now for p is equal to 1, we can again we will be using equation number 5 here in this equation. if P is equal to 1, so that means T plus 2Q plus 3, so 4 minus 3 will be equal to 1, so T plus 2Q will be equal to 4 minus 3 means 1. So here, as we can observe, that T plus 2Q is equal to 1. So again the procedure is similar when T plus 2Q is equal to 1. So that means again we will be starting from the highest order link, which is quaternary link. In this equation are connecting two links, so quaternary link can assume 0 value. For example, so above equation shows that Q is equal to 0 necessarily, because Q can only adopt 0 value, because if Q is equal to 1, so that means T plus 2 is equal to 1, or 1 minus 2 is equal to minus 1, so T will be equal to minus 1, so that is impossible. So Q can only adopt 0 values in this equation. So this will be our own decision by the observing the equation. So in this way T is equal to 1. So equation 2.4a, the other equation that will be giving that T is equal to 1 and Q is equal to 0 and P is equal to 1. So in this way total links are 10, so 10 minus 2 is equal to 8. So the fourth combination for L is equal to 10 and M is equal to 3, that will be equal to B is equal to 8, means 8 binary links, 1 ternary link, 1 pentagonal link, and quaternary link and hexagonal link must be 0. So both values of P has been satisfied, so fourth combination has been obtained. Now the last combination that actually remains, because all combinations or 4 combinations have been obtained for H is equal to 0, so the other value for H was 1. So for H is equal to 1, we can see from the previous or starting equation, as we can see here, we had started from this equation, because this was the actual starting equation number 4, where we had said that H can adopt 0 or 1 value. So for H is equal to 0, 4 sets have been obtained. So now for H is equal to 1, so if H is equal to 1, we can observe that T plus 2Q plus 3P will be equal to 4 minus 4 which will be equal to 0. So the same thing has been used here, as we can observe that in this case necessarily if T plus 2Q plus 3P is equal to 0, that means that none of the ternary, quaternary and pentagonal links can adopt or assumed other value than 0. So that means T, Q, P and all must be 0. So using the other equation which actually connects all the number of links, so we can assume that there is one hexagonal link, so this equation will give you binary links. So 10 minus 1 is equal to 9, so there will be 9 binary links. So the fifth combination for M is equal to 3 is equal to 9 binary links and 1 hexagonal links, and ternary, quaternary, pentagonal link all must be 0. So in this way all link combinations found for 3 DOF and up to 10 links and to including hexagonal order found out this way. So a tabular approach has also been used, and student must be well conversant and have full command with this technique. So a tabular approach for easy and fast calculation for L is equal to 10 and M is equal to 3 is shown below. Reference page number 45 of Book of Design of Machinery, 6th edition. So here actually the author has make us understood make us understood the procedure here like this, that in the fourth case, so I have assumed and adopted the same procedure, which I can show here, that the tabular approach for L is equal to 10 and M is equal to 3. So here we can observe that the same set of equation has been used, and I have already explained in another video for DOF is equal to 1 and L is equal to 10. So briefly I will again be explaining here that because the here in the equation 2.6 there is L minus 3 minus M and M is equal to 3, so minus 3 minus 3 is L minus 6, so T plus 2Q plus 3P plus 4H. So if there are total number of links 10, so 10 minus 6 will be equal to 4. So B plus and the lower equation B plus T plus Q plus P will be equal to total number of links, which is 10. So this will these two sets of equations will be our starting equation. So again if we observe the first or upper equation, so we will be starting from the highest order number of link, which is hexagonal. So start from its binary values means lowest count 0 and 1. So if we assume that H is equal to 1, we can observe that T plus 2Q plus 3P plus 4 is equal to 4. So that means T plus 2Q plus 3P is equal to actually 0. So that means all T, Q, P must be 0. So T, Q, P are all 0. So the lower equation will give the number of binary links. So the binary links will be obtained that 10 minus 1, which will be equal to 9. So B binary link will be 9 and hexagonal link will be 1. So in this way first set will be obtained for hexagonal 1. So if the other value H is equal to 0 is used, so we observe that the equation is reduced to T plus 2Q plus 3P is equal to 4, and the lower equation is reduced to B plus T plus Q plus P is equal to 10. So in this way we observe that in this equation further we observe that the highest order link is pentagonal link. So we will again be starting from its lowest number or count, which is equal to 0 or 1, because a pentagonal link cannot assume or adopt a value greater than 1, because if for example pentagonal link is equal to 2, P is equal to 2, so that means 3 multiplied by 2 will be 6. So on the right hand side there is 4, so 4 minus 6 will be equal to minus 2. So T plus 2Q will be equal to minus 2, which is impossible because none of the T or Q can assume or adopt a negative value. So that means P can only adopt 0 or 1 value. So if P is equal to 0, so that means T plus 2Q is equal to 4 here, and the lower equation will give B plus T plus Q is equal to 10. So we first solve this set. So again here T plus 2Q is equal to 4. So Q here the highest order link is Q, and we start from this Q. So we can observe that Q is equal to Q can obtain can assume or adopt these three values, because Q can be 0 or 1 or 2, and Q cannot be greater than 3. I am again and again repeating this procedure so that student will memorize this procedure just for explanation. So if for example Q is greater than 2, So that means 2 multiplied by 3, that will be 6. So on the right hand side there is 4. 4 minus 6 will be minus 2. So t will be minus 2, which is impossible because none of the links can assume or adopt negative values. So in this way these are only valid values for the quaternary link. So if q is equal to 0 in this equation, we can observe that ternary link will be 4, and the lower equation will be giving that 10 minus 4 will be 6. So binary link will be 6. So here the set will be obtained, that will be binary b is equal to 6 and ternary link will be 4. So 6 plus 4, so 10 link have been satisfied. So if q is equal to 1, we can observe that t plus 2 is equal to 4. So 4 minus 2 is equal to 2. So ternary link will be 2, and the lower equation will be giving q is equal to 1 and ternary is equal to 2. So 2 plus 1 is equal to 3. 10 minus 3 is equal to 7. So binary link will be 7. So binary link will be 7, ternary link will be 2, and quaternary link will be 1. So 7 plus 2 plus 1 is equal to 3. And this, when q is equal to 2, we can observe that 2 multiplied by 2 will be equal to 4. So 4 minus 4 will be equal to 0. So ternary link will be 0, and the lower equation will be giving that 10 minus 2 means quaternary link are 2. So 10 minus 2 will be equal to 8. So in this way binary link will be 8, quaternary link will be 2. So 8 plus 2 is equal to 10, and in this way these three sets for p is equal to 0 have been solved. So now we proceed towards p is equal to 1. So as we can observe that if p is equal to 1 here, so t plus 2q plus 3 is equal to 4. So 4 minus 3 is equal to 1. So t plus 2q will be equal to 1, and the lower equation will be reduced to b plus t plus q, and p is equal to 1. So 10 minus 1 will be 9. So in this way equation will be obtained. Again the procedure will be same. Here we can observe that q can only be 0 in this equation, because q cannot be 1, because if q is equal to 1, so that means 2 multiplied by 1 is equal to 2, t plus 2 is equal to 1, 1 minus 2 is equal to minus 1. So t will be equal to minus 1. Again ternary link will be, obtain or assume adopt the negative value, which is impossible practically or physically. So that means q can only be 0. So q is equal to 0, that means t is equal to 1, and in the lower equation will be giving that 9 minus 1 will be, binary link will be 8. So binary link will be 8 and ternary link will be 1, and pentagonal link will be 1. So 8 plus 1 plus 1, so this is equal to 10. Hence in this way all sets have been obtained using this tabular approach. Students are required to understand and be well conversant with this technique of tabular approach for using number synthesis for higher order links and greater number of links. So in this way now we can again verify all the sets. This is first set, so this is second, third, fourth and fifth. So all fifth sets have been satisfied. So in this way here the table has been made in a similar manner, as we can observe that if there are 6 links for DOF is equal to 3, so all will be binary links. So again n by 2 means total number of links divided by 2 has been counted here. So that is 3, and the highest order node here, the highest order link is binary link, so it has 2 nodes. So 2 is less than 3 means half of the total number of links. So actually the rule is the linkage is valid if the highest order link nodes are less than the half of the total number of links to be connected. So if the nodes in the highest order links are less than the half of the total count of the links, then the linkage is valid. So in this way 2 is less than 3, so this is a valid linkage. And if links number are total 8 for 3 DOF, so it gives the two sets, and here n is equal to means 4. So here the highest order link is ternary link, and ternary link has 3 nodes, so 3 is less than 4, so this is also a valid set. Again, this third set is equal to, here the highest order link is quaternary link, and quaternary link has 4 nodes, and here 4 is equal to 4. This is also valid because that must be the highest order nodes must be less than or equal to the half of the count of total number of links, so this is also a valid set. So after that there are 5 sets of 10 number of links. So the first set is 6 binary links and 4 ternary. So here the highest order link is ternary link, which has 3 nodes, and as we can observe 3 is less than 5, so this is also a valid set. And in a similar manner, in the second set, the highest order link is quaternary link. Quaternary link has 4 nodes, 4 is also less than 5, so this is also a valid set. So in the third set, the highest order link is also quaternary, which is 4 links, 4 nodes, so 4 is less than 5, so this is also a valid set. So in the fourth set, we can observe the highest order link is pentagonal link. So pentagonal link has 5 nodes, and the half count of the total number of link is also 5, so 5 is equal to 5, so this is also a valid set. And the last set is equal to 9 binary links and 1 hexagonal link, and here we observe that the highest order node hexagonal has 6 nodes, and the half count of the total number of link is 5, so 6 is greater than 5, so this is an invalid linkage according to the statement or line which the author has stated on page number 48 of the book of Design of Machinery, that the highest order link in a linkage cannot have more nodes than n by 2, where n is the total number of links. So according to this statement, the linkage validity has been tested. So in this way, this video actually states the possible number of links for 3 DOF up to 10 number of links and hexagonal order. So if you have any question, you can frankly ask. And thank you, and assalamu alaikum. God bless you.